I've seen a couple of videos lately on YouTube, guys, that frankly confused me when it came to their explanations of a particular system. And I think maybe there's a wee bit of a misconception out there when it comes to solenoid control valves. There's a couple of different ways they can actually be utilized in the automotive realm, right? Well, industrial design as well, for that matter. But there seems to be a misconception that the analogy of a fuel injector will suffice when it comes to control valves of all sorts. You know, a fuel injector is pretty straightforward, pretty simple. You understand, you know, you have the body, you have the coil, you have an armature and a pintle, and as you apply current to the coil, it will lift the pintle and you'll get the stream of gasoline through the valve. Pretty simple, pretty straightforward. Note there is an inlet and an outlet. Pretty straightforward to imagine the operation. It's just essentially again, the pintle that lifts from the seat and allows the flow of the fuel to go through. So this valve will operate at the same rate of the pulse repetition frequency, right? You know, generally it's duty cycle or pulse width modulated. So as the pulse comes in, it'll lift the pintle. As the pulse drops off, the pintle will drop and the fuel flow will cease. Pretty simple, pretty straightforward to see the correlation. The on time is not the same as the flow. There's a wee bit of a delay because everything has inertia, but that's beyond the scope of the video here. We're just making a simple distinction between the two. So pretty straightforward, right? One inlet, one outlet. As the pintle lifts from the magnetic field that the coil actually forms when it's powered, lifts, fuel goes through. Simple, straightforward. But some guys seem to take this design, the internal workings of this, to the extreme to explain other things, right? Like variable valve timing, or some cars will actually have variable displacement compressors when it comes to their air conditioning system as well. It's not the same thing, right? So let me go to another James Halderman drawing here on his textbook. These couple of drawings are from James Halderman's books, guys. Great books. Look into them if you don't know who he is. So this particular drawing is actually giving you cam phaser or variable valve timing actuator, and it's showing the workings of this, right? So here is in schematic simplified form, obviously, is the valve itself. You can see we still have the coil. In this case, it's actually a spool valve. It's not pintle. You can see that we have the oil pressure that comes in the case of variable valve timing. It might be refrigerant pressure in the case of an AC system, but in this case it's oil pressure. We're looking at the cam phasers here, variable valve timing. And you can see that the major difference in this design is that this is designed as a linear stroke. It is not just lift it and drop it. This can actually be pre-positioned, again determined by the pulse width modulation. Essentially this is reacting to the average voltage that the pulse width modulation is going to afford to the system. So it might be wound a wee bit differently, the circuit might be a wee bit different. It's not designed to simply lift it and drop it. It's designed to stroke it to the left and to the right in order to, my dinner's ready, sorry about that. Hang on. Very good, very good. So where were we? Yeah, the oil pressure comes in, and depending on what pulse, how the pulses are actually applied to the coil, the average voltage would be different, allowing the spool to actually spool to the left or right, porting the pressure, in this case, to the brown or the yellow port in order to rotate. This is a rotational actuator. Rotates depending on the differential pressure and how it's applied to the ports, and there's facility to actually vent that same pressure. If you wanted to rotate in one direction, no likelihood you're going to want to vent the pressure to the other chamber, if you follow what I mean, guys. It's kind of like a hydraulic piston. Usually when you want to stroke in the other direction, you want to relieve the pressure so there's not a lock. Make sense? So that's the main difference, guys. You can see this is only designed for a lift and a drop, and this is designed to operate at variable positions. The spool valve is not simply shuttled left and right, but actually spooled to the left or right in a linear fashion in order to get the differential pressures, in order to achieve the valve timing that this is looking for. Hope that makes sense. So here I think is quite an obvious difference. Here's a fuel injector, right? And the electrical connector for obviously the coil that forms the magnetic motive force, which then lifts the pintle. The inlet pressure would then bypass the pintle and spray into the combustion chamber, obviously, right, into the cylinder. This is just a generic drawing I pulled off the web somewhere, guys. This is an oil control valve, or sorry, this is actually an AC valve, but it's again essentially the exact same thing. And you can see there's two ports shown here, right? You can tell there's different chambers. It's not just a single O-ring like a fuel injector. You can see that this is actually segmented into different ports, 3 in this case, right? So the inlet pressure would come in this case. Again, this is refrigerant pressure in this case. And as the spool valve is shuttled to the left or to the right, the stroke of the compressor could be altered by altering this differential pressure. It is not the same as an injector. This operates in a linear fashion, left or right, in order to port the pressure differentially here. This is simply a lift and pump operation, right? Simply shuttling it up off the seat and then back onto the seat in order to achieve your air-fuel ratio, depending on just how long you open the pintle for, right? So significant difference between the two, guys. Again, from James Halderman's textbooks. I hope this clearly shows you the distinction between the two. It's easy to tell because typically speaking, a spool valve will have more than one port control. This would be the inlet pressure, and then the two control ports, sometimes actually operating as a vent port at the same time. Simply dumps it, it either applies pressure or dumps it. For a simplified version, as opposed to this drawing makes it a little bit more complicated looking, but it's not really, it's the same thing. Right, that's it, boys. Difference between fuel injector and a linear stroke spool valve. That's it, boys. Cheers.